Welcome to BLU meeting on July 16th, 2025. We're going to be talking about Grist, which is an open source point and click database system presented by Brendan Kidwell. And Brendan, you can go ahead and start.
Okay. So thanks for having me at Boston Linux and UNIX. I'm Brendan Kidwell. I'm a software developer with, I don't know, at least 25 years of experience at this point, who's counting. I work for a big government consulting company, and I've been in various kinds of IT and project departments in the same company ever since I finished school. And so I'm basically a web developer and a jack of all trades of things that touch web development. And that's about as much info as you need about me. My website is glump.net, glump.net, if you want to know more about me. And while we're giving URLs, all of my notes and the exhibits that I'm showing in this talk are at go.glump.net/grist-blu. So if you're watching now live, or if you're watching a recording of this, definitely you want to pull up my notes and the attachments that I gave there. Oh yeah, and I said before we started recording, if you want to interrupt me, please do. We've only got a few people in the audience, and feel free to turn this into a conversation. I don't mind. I don't get upset if you interrupt me, so please do. So first I want to make a quick point, and I think this can be quicker than in some other venues where I've done this, about what's the difference between a relational database and a spreadsheet. And you go and look at that in here, and there's no, this borrowed, you would think that you could design something where this borrowed column would reflect the fact that it's checked out, but it hasn't been checked back in. And yes, I believe you could actually program that in LibreOffice Calc, but it's not really what spreadsheets are for. And whenever I've tried to do one table related to another in a spreadsheet app, whether it's Excel or Calc, I just end up fighting with it. And besides the relating two tables to each other, sometimes you're fighting with the formats, and you say that this column is supposed to be an integer or it's supposed to be a date, and then it ends up formatting something else weird when you type in something that's not quite the format it is expecting, and somehow suddenly the entire column becomes a text column instead of a number or a date or a year. And another little thing, well, not so little if you're tracking big data, big pieces of data. Excel and LibreOffice Calc do not handle long cells very well. If I make this cell smaller, just glancing at it, just this tiny little red arrow says, hey, there's more here. And how do I see that more? It's not immediately obvious. Right here, I've got to double click on it. So spreadsheets really excel at doing what they were invented for: quick calculations where cells depend on other cells, and running models of stuff and trying to figure out the best way to solve a problem. They can do single tables okay, but I've never had good experience doing multiple tables. Now contrast that with, I converted that whole idea into Grist, which is the database product that we're going to be demonstrating here. this borrowed column is actually, this isn't a piece of data here. It's a, I gotta go to the column widget. It's a formula that says sum up, it basically find whether this item is checked out or not. And it refers to the other table. You know that spreadsheets get kind of fiddly when you have thousands of rows in a single table. And when you have multiple users, they get even more fiddly. And there's kind of partial solutions for that out there, but they all don't work very well. So now, let me tell you about why this topic, Grist, the database program, is such a big deal for me. I actually got my start in programming in college, working in a lab that did quasi-commercial work for people outside the school. And in this lab, we built software to solve problems. It was focusing on geographic information systems, but that's not relevant to the story. I learned to program in Microsoft Access and with later with Visual Basic 6 and some other stuff. But Microsoft Access was really where I got going. And I grew up and I got better. And Microsoft Access has not. If you've ever used Microsoft Access, you'll know that it's a very impressive piece of kit from around 1994, 1995. And they upgraded it a few times. They added some more features. It was a big deal in like Access 2002. They added the calendar control to pop up a date picker. That wasn't built in before then. But there's really a lot of, besides the fact that Microsoft Access is proprietary, there's a lot of stuff that just doesn't work very well with the modern world in Microsoft Access. If you want to connect Access to the internet and access REST APIs or anything like that, forget it. Nobody's in their right mind would do that today. And the worst problem that I had back in the day was Access really sucked at importing and exporting text files. I remember, and this has not changed, if you want to import a text file into Access and you say that a column is the type of a column is date, you have like 20 kinds of dates that it could be, 20 different date formats. And if it's not one of those 20, you can't import it. The best you can do is import it as plain text, import that column as text, and then you have to write a macro to post-process that and convert that text into an actual date. You can't, in the import process, just say, let me spell out the format of this date column. So I tried a few other things over the years. There's Kexi from, I think it's from the KDE project. Every time I start up Kexi, it just crashes. And that has not changed. Every time a few years go by, I try Kexi again, it just crashes a few minutes after I start it. And LibreOffice has base. And that's descended from OpenOffice.org base and all the other versions of what became OpenOffice and LibreOffice. And if you've ever tried base, you find it's really like, base is like it's like a rich text editor with tables shoved into it. And it just doesn't work well for tables. It feels weird, and I could never get into it. So last year, I think it's probably about a year ago or a few months, maybe 6 to 12 months ago, I found out about Grist. And Grist is an open source application, and it is, where am I in my presentation? I forget my notes. Grist is open source. It's available as a desktop application, although the website doesn't really, the main website doesn't make it immediately obvious it's available as a desktop, but they do make a desktop build. It's built around Electron. It takes per year, and $24 per user per year if you want priority email support. So count that as basically $8 per user per year is probably what you're going to go on. And that's great for anyone who doesn't mind putting their stuff in the cloud. But it's open source, and they ship it also as a Docker container that you can just download it and install it yourself on your own server. You can use it in a commercial capacity and totally on your own server. You can use it as just a regular user, as a home user. It's free software. So now, when I actually tried out Grist, I immediately noticed the first thing I did was I tried to import a text file, and lo and behold, I don't actually have a text file here ready, but we'll hit the import from file, and I should have prepared one ahead of time. Oh, let's export and then import a text file. That's good. So download as a CSV, and let's go to the folder where I'm working. All the Linux people, I apologize for using Windows, but that's just the way we are with this computer. Now let's import that file that I just exported. And it didn't get the cover image. That's kind of a special case. Don't worry about that. But you select the file, and it shows you all the columns, and you can edit the columns, I think. Import options? No. Okay. Never mind that. But this is how import looks. And after you import it, you can easily say, if it detected the column type wrong, you could change it. And what happens if I change it to date? Oh, that worked. It's a date with only the year field filled in. And it doesn't ask you about formats, but I'm not telling my story very well because I don't have an example for imported dates well, but it exports and imports text files much better than Access. So anyway, long story short, Grist is the spiritual successor to Microsoft Access. It is available as a desktop application, as a server application that you install on your own server, and it's available as a cloud service. You pay them to run it. And there's also a free, up to 5,000 rows, free version of the service. And after I've tried this, I never wanted to do anything in Access again. This gets the job done. So let's see, what haven't I covered in my notes? I covered the tiers. Okay, so let's show some examples. In the Help Center, in the Help Center, there's a page of examples. And this demonstrates another really cool feature about Grist is that you can share a Grist database just simply as you put a file on an HTTP server, and then you wrap it in an HTML file. And if you just have in the HTML file just this really simple bit of code, say you've got to load this Grist JavaScript file, and then give it a little bootstrap invocation there. Let me go ahead and demo this right now. If you're not familiar, Python has a basic, simple HTTP server built into it, and I just invoked that. localhost 9.1/library. And there, it just loads it straight up. And again, the cover images didn't work, but don't worry about that. If you need to deal with images, then you can figure that out. But I could take these two files, the library.html and the Grist library.grist, and just put those on a web server somewhere, and I could use that to share a data set. And the entire file has been loaded into memory in the browser, and it's running. It's basically running offline in the browser's memory at this point. And I can do things like edit this and say, I only want to see stuff from Paramount, and then it lets me do that. And I can add a new tape. I can add a new page in here and say, table, let's show the borrowers, add page, and let's show only the borrowers that actually have an active checkout. And I can call this page active borrowers checkouts. And again, this is all still running in the memory. So if you want to publish a data set and say, hey, just go to my website and play with my data set, you can just point them to this, and it's a great way to give an interactive view. Go ahead. Somebody say something.
When you say just put a file somewhere, I'm assuming when you say or have it hosted, you know, the HTTP, that's a Grist database file?
Yes. So
okay.
This URL here is loading library.html, which is this file here.
Yeah.
And that is referring to library.grist, which is just this other file in the same folder, library.grist.
And that's the actual database.
That's the whole file. That's the entire system. That's all the. It's actually in the form of an SQLite file if you open it up in an editor.
Yeah, so, I got it.
Yeah, so you just drop that SQLite file in the same folder as the HTML, and you serve it with an HTTP server, and then somebody can go and play with your data set directly in the browser.
That's excellent, but that's also assuming you have internet access to get the Grist JavaScript, correct? Or
yes. Okay. If the viewer that you want, if you want to send somebody to a file, if they don't have OS, the Linux, the Windows version of the Grist desktop program, and then give them the Grist file. But copying a Grist file is just this one file.
Excellent.
Okay. So I was going to show examples besides my own example. In the examples section of the manual, by the way, the documentation is very good. It's definitely not complete. It's like, you know, it's not like those 600-page books about how to do anything in Microsoft Access. But if you have ever done anything with databases, everything in the documentation is going to make pretty good sense to you. With the caveat that it's the interface that you see kind of steers you clear of SQL. The macros are actually written in Python, and it's got Python running inside the client. You know how you can build Python as a JavaScript application. That's beyond the scope of this talk. But the expressions are all Python, and if you want to do anything with SQL, you're going to want to open the database in SQLite editor and do your SQL in there. But the focus of this is on, you know, it's kind of like point and click programming. You're not supposed to be messing with code as much as possible. So with that in mind, I think the manual is pretty good. It has a lot of great examples. That's what I was getting to here. So let's open up payroll. Now, I wouldn't recommend you do enterprise payroll in a system like Grist, but if you're a two-person shop, you might start here. And so again, we just loaded this Grist file into the browser with their Grist viewer, and I can do what I want with this file, and I can see how this file is programmed. And you can go to the column properties. You can see how this is a reference to another column in another table, etc. So to learn, you basically just read through the manual and open up some of the examples and look at how the examples are programmed, and that will that'll help you get going. So now let's do, let's actually talk about how I built this library database. So I'm not actually going to start from scratch. I'm going to show my stuff that I have. Oops, no, sorry, lost my place a moment. So this library database, I'll show you a couple of features of it. When you're building a relational database, if you've never done it before, basically you want to think in terms of what are my entities, and how can I explain an entity really quickly? An entity is like, it's like your root object. And you can see the examples of the entities that I have here. Items, medium is just a type, series, creator, borrower. So an entity is a thing that has attributes. It's the container. Your types of object is your entities. And each of your entities, you're going to want to create a table for that entity. And in Grist, you create a table by creating a page, add new page, and then table, and then you can say new table, and it's just going to ask you for the name. I'll call it new table. And it just gives you a blank. It's spreadsheet-like. Here's your empty column A, B, and C, and you can rename your columns like this. And by the way, you don't have to have an ID column. You see that in my my items example here. It has a row number, but you don't need to worry about that. And you don't need to create IDs. What you do need, though, is if you don't have a title, you're probably going to want to create an ID. But where do I want to go next? So here's one thing that's you'll find different from spreadsheets. I wanted to have this this medium type, this data type of, is it a DVD or a Blu-ray or an audio CD? And when I write data into this column, I want to be picking it from a drop-down list. Now, you can do drop-down lists in spreadsheets, but they tend to be loosely typed, and it's not like, it doesn't enforce it and say it's got to be one of these. And further, once I choose, this is the way that I did this, enforcing the data type here, is that the medium column is a reference to the table medium, and then it says show column. So this is where you have to have a title or an ID or something that makes it different from all the other records. But Grist itself does not require you to actually create an ID column. It creates a row ID for you. So anyway, this is a reference to the medium table. And from here, I pick one of these mediums. And then this over here is also a column in the medium table. You see I have a DVD is a type video, Blu-ray is a type video, etc. And to make this column work, I just had to simply make a formula that just says medium, that's this column here, and then dot type, that's this column within the entity medium, it pulling that, and it's displaying it here, and that's how I refer to it. And then whenever I change this value here, change that to hardcover, it changes medium type to book for me, so I don't have to worry about updating that myself. Details. So another difference you'll see between this and spreadsheets, which is really handy, is you can show some of the columns up top, and then you can add a card view. So let me start a new page, and I'll demonstrate how this works. Start one more. Items new. Show the items table, add page. Let's call this items new. So I just created a new page that's only showing the items table. And I want to make it look like this one back here that I already prepared. So the first thing I want to do is add a card to this page. add a widget, sorry, add a card widget. Add widget, and then card, and then the card is going to be based on also the items table. And then I'm going to say, I just want to show items. And then that's going to give me this nice card view over here. And I'm going to drag it to the bottom so that I get more columns up over the top. And now that we have this card down the bottom that has all these details, we don't need all these details up at the top. So I'm going to hide these columns. Can I select more than one? Nope. I'm going to work one at a time. Let's put the cover over here. We don't need the, well, let's keep the asyn up there. Physical description, we can hide that. Synopsis, we don't need up here. Synopsis was the description column that I was looking for. Borrower, let's keep that. Why is medium type in here twice? And yeah, we don't need that. Okay, so I took away some of the columns on the top, showing all the columns down the bottom. Now you can also remove stuff from the bottom too. I can say edit this card layout, and let's say that we didn't want to show the if we didn't want to show cover, how would we do that? Widget, and scroll down to cover, and I can hide cover, and it goes away from there. Don't know why I had to click that so many times. And I noticed that synopsis is down here with our synopsis. It could be a really long piece of text. So I want to edit the card layout, and then I'm going to drag synopsis down to the bottom, and I'm going to edit the field and say, make this oh, and by the way, Grist supports Markdown as a text. You can write in Markdown format. And when you're in view mode, it shows it formatted as HTML. I think with this button, which really ought to have a tooltip, it doesn't have a tooltip. But I think this button turned on says that to automatically make it get bigger. Well, if you want to know how to make that work correctly, read the manual or read the forum. We're going to skip that because I don't know how to fix this right on the fly. I am very excited about Grist, but I've only used it like a few hours here and there to solve a few specific problems. So I'm definitely not an expert, and this is just kind of a quick overview demo kind of thing. Is there anything else that I wanted to show in the library demo? I'm looking at my notes here. So checkouts. The way I designed checkouts was I just said that the item is a reference to the items table, showing the column lookup name. Oh, and what's that lookup name? Let me show that. I'm going to go into raw data because it's hidden on the main page. Items, edit the items table. Edit record card? No. Items. There we go. So I added a computed field over here somewhere called item lookup name. So in order to make this widget here under borrowers, checkouts, in order to make this widget here nice and compact with a few bits of details, but all squished into one field, so it works nicely as a column in a table. We see we've got the title, we've got the media type, the creators, and the series name, and that's all squeezed in with square brackets, decorating it. The way I did that is go back to raw data, items, lookup name. It's a formula, and again, this is a Python expression. So I said start with the R, that's my result variable. Start with R as just the title as an array, a list or an array, depending on what programming language you like to speak in. If medium is not none, then add this value to the result. And if creator is not none, add this value to the result. If series is not none, add that to result. And then join all the stuff together with spaces in between, and then return that as a string. That gives me this column, which I can use as in the checkouts here, I can say show column lookup name, and it squeezes all those fields nicely together into a single string. So when I create a new checkout, I can pick a date here and pick a person, and then pick a thing that is checked out. And I didn't put in a rule that the same item must be checked back in before you can check it out to someone else, but I'm sure that there's a way you could program that. What else? All right, let me show you a demo here. Let me show you a database that I actually use to do real work. I have a PO box because my mailroom in my apartment building is not very secure. So I rent a PO box near the subway station, and we get, at one point when I created this database file, we were getting a lot of mail. My wife orders a lot of stuff on Amazon, a lot of Poshmark, Chewy, other stuff. We were getting like 4 or 5 packages a week at one point. So it was getting crazy because I would go there and I'd say, give me my packages, and they give me 3 packages, and I come home and find out that there was one more package that they had, but they didn't notice it. And now I have to go back to the mailbox store and get that one that they already had. They should have given it to me. So I created this to track all the packages that we have ordered. Here's the packages list. So all the packages that we've ordered sorted by tracking number, and who was the vendor, who's the mail carrier, and you could do this automatically. You could use, Grist has a HTTP API that you can use to write an external script that can go and pull stuff from the internet and insert stuff into your database. I didn't go there. I just said manually, before I go up to the mail store, I just take all the package numbers that are, let's say the phase is filter to, actually I've got a page for that, package status. Current packages. I was in the right place. So this shows, this is all of my packages. This is the same table here, but it's only showing the packages that aren't finished. And the data is out of date because you're looking at a redacted version I did a few months ago. But I would go to my current packages list, and everything that isn't done, I would look up that tracking number on the internet and then write in what is the current status. Has it arrived? Has it delivered? Is it still in progress? Is it delayed? And I have a ETA field over here, and I could say that this is due on the 25th or whatever. And then I would take this, and because I installed the server version of it on my personal server, I created a package dashboard. Now this looks better if you use a narrow window. I load this page up on my phone, and I'd go into the mail store, and I would just go through my package tracking dashboard. And I would say, okay, I'm expecting this one and this one and this one. And so you need to give me 4 packages because the online services said they're all delivered. So that's a practical example of something that you might build for yourselves. And if you wanted to do exactly this, just copy my file and change it. So that's about it for the demo. I have some more final notes. I can just find them here. Good uses for Grist include things like I showed you, track my library stuff, do some really small business stuff where you're not having lots and lots of users. Task management, it's something you might do. Keeping track of activities for a club. Everything that you saw in the documentation page about examples, those are all good things you do with Grist. Some things that you might consider using another system for would be a calendar or a date book. Now you saw that it has a it has a date picker, which is nice. But as far as I know, and this may have changed, it doesn't actually. You saw in the examples there was a graph widget. I don't think that there's a widget for a calendar view or calendar grid. So if you wanted to use this as a date book, it probably wouldn't work out well for you. You might want to use whatever comes with your email or Thunderbird or something instead if you want a calendar. For notes or a diary, I would recommend Zen Desktop Wiki or Obsidian Notes or some other kind of note-taking tool. If you want to do some heavy data analysis, like doing modeling, like what's the best way to solve this with all these different input parameters, that's where spreadsheets shine. That's what they were built for. And if you didn't want to do it spreadsheet style, you could use Jupyter Notebooks. That's a really good tool for doing data analysis, reproducible data analysis, where everything, all the inputs and outputs are stacked in chronological order from top to bottom in a document. Jupyter Notebooks is great for that. And this, not so much. Now, if you have lots of users, or if you have gigabytes of data, or if you have if you need enterprise level access control beyond just like Bob is an editor and Dave is a reader, if you need to go beyond that, that sort of thing, you really should be using something that besides Grist. But for small projects and just this really simple point and click programming, where you just drag things around and say, create a new page, create a new widget, Grist is great for that sort of stuff. Also, you can do custom forms in Grist. You can do like a form that spells out all the requirements for creating a record and say, here's some documentation before you enter this value, and here's some constraints on this value that this needs to pass through validation and stuff. You can do that in Grist, and it's kind of an afterthought. If you look in the manual or the forum, you'll see some examples of how you can use HTML and JavaScript to program custom forms. But I haven't gone there, and at that point, you'd probably be wanting to use Drupal or some other system that is really built for data entry, for complicated custom data entry. Final notes, what else I got? I showed the HTML view. I showed the package tracking. I mentioned it has a REST API. Let me pull it up. I have not explored this yet, but if you have it installed in a server, or if you're using the desktop version and you have the desktop version started up, you can access it from the HTTP API from an external program, read, write, get the structure, modify the structure. All the commands are in here as API commands. And finally, let's just go ahead and see what this looks like in the raw database. So I'm going to open up dbeaver. dbeaver is a generic database editor. It supports SQLite files, among many other client-server type of things. Let's create a new project here. Tools. Never mind projects. Open data source. Nope, wrong. On a new database connection. SQLite. Next. And open path. Let's open up the package tracking. That whenever you refer to some other table and you say the formula is going to fill it in, it actually copies that display key into the table that is making the reference. So that's an odd way of saying, if you want to write anything here, you really ought to be using the HTTP API. But if you make a big project in Grist and then say, I want to get it out of Grist and put it into another system, it's just an SQLite file, and it's not that complicated to parse through and use the raw data tables in SQLite. So that's pretty much all the notes that I have. I'm going to move on to questions. Does anybody have any questions or comments or concerns? Thanks for having me.
Thank you, Brendan. I thought that was very interesting because I had never heard of it before.
Yeah. And I can't say it enough. If you have solved problems with access before, you really need to learn Grist and see what it can do.
Yeah, I hadn't. I have used access, but I rarely use Microsoft stuff.
Yeah, this seems like a good use case if you just want a front end on a very basic, like you said, Microsoft Access thing that has a lot more features, obviously, and designed a lot better. Do you know, or have you heard of how often it calls home if you're using, let's say, the Electron client? Is there a lot of chattiness with it calling back to Grist for any reason, or is it relatively free of all of that crap?
I have not observed any of that. I haven't gone looking for it, but I will say, for what it's worth, the manual that tells you how to install the Docker version, it doesn't say, by the way, you need to have internet access or this isn't going to work. Now, there may be some phoning home that fails silently, but I haven't investigated it. But since it's open source, I would think that if it has anything like that, you could probably just cut it right out and you wouldn't have a problem. But you're probably not going to find it. I wouldn't be surprised if there's, like, every time you start it, it just calls home and just, hey, census, I'm here, but no real detail. It's not going to go through your system and steal all your data.
Yeah, I'm always paranoid about telemetry stuff. Personally, I couldn't care less, but if I go to break it into a place like where I work, or if I'm consulting for somebody and they're going to ask me, I'm fairly certain they're going to have that stuff, written out. And these days, I'm pretty sure you can just point ChatGPT or whoever the hell you're looking at to the GitHub and say, "Hey, look for this stuff." But it's good to know that you haven't seen anything.
I'd be careful about asking ChatGPT a question like that because it will confidently hallucinate anything.
Yeah, that's fair.
Yeah. But a good developer, a good senior developer, you could give him the source code and say, "Is there anything bad in here?" They'll be able to zoom in on the part that they would be concerned about and see if there's anything in there that's happening. And they can, string search for all the URLs in the program. What is it doing with those URLs? That kind of stuff.
Yeah, that's the advantage of that it is open source that you can do that. So that's a good point.
And you could always put a firewall around it. You could say that people can connect into my Grist service, but they're not allowed to connect out from Grist and do anything on the internet with it. Anybody got any stories with, I wanted to build a quick and dirty database, and here's how I did it in any system?
Whenever I want to use put a database, my go-to is always PostgreSQL.
What does PostgreSQL have in the way of, what does it have for? I just want to define my database and then throw editing forms on top of it. Is there anything built into Postgres that lets you build a front end? I mean, I know what Postgres is, but I'm just curious. Does it have I just need a really quick front end? What's the solution for that?
Yeah, I've never seen anything like that.
Go ahead.
What was that?
Oh no, go ahead, John.
I'm going to say Adminer is good for that. Actually, Adminer is a PHP program that actually ships as a single file, which can it can stick a quick and dirty front end on top of a lot of different database types. And I have used that in the past with some success.
Yeah, I mean, honestly, the most basic I can think of doing is building a quick site in Django, but that's just because that's a framework I know. If I didn't know the framework, I wouldn't suggest making that your front end. You know, even actually, the Django admin tool is a front end to a database that you could even consider using if you needed something in an emergency that was web based. But this adminer looks interesting.
Mm-hmm. I'm very happy with how Grist works as like a 2-user database on a server that was almost entirely point-and-click programmed, just a little bit of Python sprinkled in.
Yeah, I've had somebody recently ask for some sort of like almost like a membership database for their organization, but it's a very, very small organization, a small town looking for one little specific thing, but they needed a front end. And that was where I'm like, I can't. This would have been what I would have said had I been asked this question next week instead of 6 months ago. It's a quick thing that even the end user could do a lot of the setup in.
Then I've sold you. My presentation was successful.
You have. Good job.
Agree. Oh, just one question. Did you pick those names out of the blue? Or those people that you know that you had names or your borrowers?
The borrowers, I first gave this presentation at New York Amateur Computer Club in March, and the names that you saw there they're all members of the board of directors of New York Amateur Computer Club. You were asking about Dave Metzger. I don't know what his history is, but if you're thinking of Dave Metzger in New York City, then that's who you're thinking of.
No, well, we had a Dave Metzger that used to work with us at DEC in the development environment group. I don't know who he was working on, but he could have moved on.
In NIAC meetings, Dave has said very little about his past. Maybe he's a spy. New York Amateur Computer Club.
Oh, because my cousin used to be mayor of Nyack, New York.
Now different NIAC.
Yep. It's up the street a bit.
Do we want to open up to any other conversation and stories unrelated to this?
I think I'm going to watch the thing all over after I get the video from what Joe recorded. It was during a big part of it. I was having problems in Jitsi, so I wasn't seeing the meeting at all. I was just seeing my face and a bunch of icons from other people.
That's happened to me a few times. I missed an entire presentation because I thought I was still waiting for somebody else to figure out technical difficulties. Turns out my browser was just like, nope, I'm going to not show the videos, and I'm not going to tell you something went wrong.
I'm still not sure what went wrong with it, but I just shifted to a second machine, so I saw like the second half of your meeting, I guess.
Well, here's the short version of the talk. Go to go.glump.net/BLU. Open the presentation notes, follow the link to the desktop version of Grist, download it, and start creating something.
Yeah, well, you've already got the full meeting recording is already in Dropbox.
Oh, you stopped recording already?
No, I haven't stopped the recording, but I actually initiated it in Dropbox.
Oh, okay.
Can you view a file in Dropbox that hasn't been finished uploading?
Yes.
Oh, that's nice.
Well, it's Dropbox mirrors your directory in Linux. So it's in one of my directories that's mirrored up to Dropbox.
I would imagine I would imagine I have trouble playing videos that haven't finished recording yet.
Right, exactly.
You probably have to be affected the same way as if you're running a corrupted video file.
If it has the right header at the very start, then usually you can, there's like optimized for web streaming or something is a switch in some programs. If it has that right header, you can random seek inside of a file that's not finished.
Yeah, but in this case, when it ends, it will automatically upload.
Mm-hmm.
And in the past, I actually had to go and move the files over to my Dropbox directory.
Well, this is really cool. I'm going to try to get the desktop app running on a Mac, if not my Fedora box, tonight, just to have it as another tool in the arsenal of little small projects to build when somebody requests something. So thanks for the interesting intro.
Mm-hmm. Oh, I also use it at work. I don't even remember when I do this. I use it at work for turning, like, I'll load a text file into a Grist file and then do something to it really quickly, just ad hoc, add a column, compute a column, and then export it to another text file and throw that into a pipeline somewhere else. I used to do that in Access, and I would grumble every time. Like Access is the best tool in my toolkit for doing this, but I hate Access. And then a year ago, I found Grist. It's like, oh yes, I finally our modern program that can read and write text files and can do relational tables. It's perfect.
Okay, so just to be sure I got everything here. I think I saw you mention two different applications. It was Electron, and then there was dbeaver. Is that right?
dbeaver is just dbeaver is a open source everything database editor. It's for it has dozens of database drivers in it. So it's your programmer's tool for accessing a database. I use that to show the structure of the SQLite file. The front end that you want, if you want to try this, you want to get Grist desktop. Mm-hmm. And if you want to install it on a server, look for the Grist Docker container. And if you want to pay them to host it, you go to grist.com and they'll set you up.
So Electron was something else entirely?
The Grist desktop is an Electron app.
Oh, okay.
It's the same app delivered as an Electron app.
It's so you can run a web app on your computer and make it look like an actual app, but performing terribly. It's a really cool way to do that. But it satisfies a lot of needs, unfortunately.
Yeah, it gets the job done with it 250 megabytes of extra runtime overhead.
Exactly.
Or is it 500 megabytes at this point?
Whatever it wants to be.
I never understood, why does Electron not use a global, why isn't it like Java? You install Java once and then all the Java apps use it unless you need a specific version of Java. And Electron refuses to ship it that way.
Yeah, it would be nice to just have, the Electron virtual machine running or sitting there on your machine that, then you could just pull the app in and not have to download it 20 times. That makes sense.
Yeah.
It's a good question.
But when you build a Docker container that contains 3 or 4 different programming languages in it, and it's designed to be deployed as a web app, Electron will let you take what's in that Docker container and deliver it as an executable for Windows, Mac OS, and Linux. And as much as there's a lot of overhead on that, it's great for teams we just want to build this once and then just ship it all the different versions of it.